Some of the world's oldest fossils can be found at the American Museum of Natural History, but the oldest specimens aren't fossils at all. These rocks are over 4.5 billion years old, older than the Earth itself. Some are made of metal, some of stone, and they all have one thing in common. They are all chunks of asteroids that fell to Earth as meteorites. For the curator in charge of this collection, Denton Abel, they are clues to a cosmic mystery.
Learning about the solar system is intrinsically valuable to humans. In this case, we're learning about how the solar system actually formed.
Scientists believe that in the beginning there was light from our new sun, and there were rocks, asteroids that collided and melted, forming new worlds like Earth. And there was ice from comets, rocky ice balls they formed at the cold edge of the solar system. Comets may have brought their ice to the young Earth, creating our oceans. Comets are too large to fit in a hall like this, but Denton Abel would still like to get his hands on one.
What we'd really like is a piece of a comet so we can understand better the earliest solar system and how the planets formed and got their water.
So scientists need to unlock a cosmic secret. How do you catch a shooting star? In 1996, NASA scientists decided to try. They named their mission Stardust. They planned to send a probe to a comet called Wild 2, collect some comet dust, and bring it back to Earth. For mission leader Joe Valinga, there was one fundamental challenge.
The trick for Stardust was to find some way to capture hypervelocity particles. We're traveling through the coma at 13,000 miles an hour. So how do you do that? How do you capture particles and bring them back?
To capture particles, Stardust would need to rendezvous with a comet and enter its volatile tail. A comet's tail forms when it approaches the sun as ice vaporizes and erupts from the surface.
Some particles that come off of comets can be larger and some smaller. We don't really know whether even a piece of, this big could come off of a comet.
Comet grains are 6 times faster than bullets, and they will heat up when brought to a sudden stop. Conventional materials used for catching bullets aren't strong enough. Steel would be too heavy. And then someone thought of this. It's a material called aerogel.
Aerogel is the least dense solid known to humans, and it was invented and perfected over the second half of the 20th century.
On the atomic level, its nearly random structure gives aerogel foam exotic properties.
One thing that's very important to know about aerogel is what a good insulator it is. You can see we're melting the aluminum, but the wax is just fine.
Since it can stop heat, engineers wondered if it might also stop comet dust.
Turned out through tests that aerogel could stop particles traveling at velocities even somewhat higher than 13,000 miles per hour. You could capture very fine particles similar to what would be in a comet coma. We had confidence that the aerogel was really going to work.
Joe also knew that no material is perfect.
This is about a half-a-pound meteorite.
Aerogel can stand up to significant force, but it's not invulnerable.
This is about 2 pounds.
And this supermaterial has its own form of kryptonite.
This is ordinary distilled water. What happens is that the water collapses the structure of the aerogel foam itself.
Even with these downsides, Joe's team made the collector tiles from aerogel. In all space missions, risk comes with the territory.
10.
On February 7th,
8,
1999, Stardust
6,
blasted off.
4, 3, 2, we have main engine start, 0, and liftoff of the Stardust spacecraft.
On a curving trajectory, it would take 5 years to reach its target.
The body of the spacecraft is about the size of a telephone booth. The aerogel is hidden in here, and it folds out. First an arm folds out, and then expose the aerogel grid so that it can collect the cometary particles. Prior to actual encounter, what we had was test data that indicated that, yes, we'd probably be able to stop the particles, but you never know for sure what you're going to get. I remember the day we were getting ready for the encounter with Cometville 2. I was in this room when we deployed the aerogel grid, and we watched the telemetry data coming back. We could not tell, though, what happened with collection of the particles. So it was a 2-year long wait.
On January 15, 2006, the Stardust sample capsule re-entered Earth's atmosphere at 7 miles per second, becoming the fastest human-made object to return to Earth. No one was sure if the aerogel could withstand the force of rapid deceleration.
Would it in fact shatter when we landed?
Recent rains had flooded the Utah landing site.
There was also the danger that the capsule itself would be penetrated by water upon landing.
The recovery team retrieved the capsule with its sample canister. But did the aerogel catch part of a comet? To find out, samples of the aerogel were distributed to scientists around the world, including Denton Abel of the American Museum of Natural History.
This is an actual sample of the Stardust return sample suite.
Under high magnification, the sample reveals the microscopic trail of a comet particle.
You can see here where it's been fractured, the actual fracturing in the aerogel due to the effect of the impact.
The fascinating thing about some of the results from Stardust, high temperature materials have been found in the particles.
High temperature solids would be the kinds of minerals and magnets you'd see in terrestrial volcanoes, for instance.
So at least some comets didn't start out as rock and ice at the edge of the solar system, but much nearer the sun, colliding and melting like asteroids. And the aerogel samples contain another surprise: organic molecules needed for the creation of life. So when comets came to Earth, they may have brought more than just water.
One of the possibilities is that comets seeded organic material that started the evolution of life on Earth, because the Earth was too hot to support organic compounds in the beginning as it cooled. So where did they come from? Possibly from comets.
The American Museum of Natural History now has one more tiny rock from outer space. And as far as curator Denton Abel is concerned, there will always be room for more.